Today we're working on class rec 6.1 or 4.5. We're going to be graphing sine and cosine waves. So first thing to do is in your notes, write down the formula I've written on my paper already. This is what I call standard form, meaning you want all of your equations to look like that before you graph it. So it'll be important to understand this, and I'm going to box that because that's pretty much all we need for today. I recommend you do the same. Let's quickly note a couple things. A is your amplitude. So hopefully you recall that word from your trig class. And I write the absolute value of A because we want amplitude to be positive. B is going to relate to your period. That's going to be 2 pi over B. And again, I put absolute value because you want your period to be positive. That C is going to be your phase shift. That's your left and right shift. And of course, K is your vertical shift, but in my classes, I refer to it as the midline. And I'll show you what that means in a little bit. So hopefully you recall some of that from your trig class. If not, make sure you see your trig notes, and you can ask me for help too as well. But I'm going to go through this a little fast because all you guys have taken trig. So first part is, here's your equation. Your amplitude we can already see is 3. Period is going to be pi, and that's because you plug in 2 pi over 2, and that's pi. Now the way I want you guys to graph these, we're going to graph one period. You're going to make a T like this, and just make 4 tick marks on the x-axis. 1, 2, 3, 4. This fourth one right here is you're going to be your complete period. Meaning you're going to put your period value of pi right there. Now all we're going to do is figure out half of that. That's right here, pi over 2. Half that again, that's pi over 4. And the third one should be 3 pi over 4. The amplitude is going to be your y-axis value, so that's going to be up 3, down 3. And of course, there's your 0. Now it's a sine curve, which means you're going to start at the middle. It's positive, so we're just going to go up. So right here is our sine wave. Let's connect all your dots. And there you go. There's one complete sine wave. And we want to label this, so this is 0, 0. That's pi over 4, comma 3. That's pi over 2, comma 0. 3 pi over 4, comma negative 3. And that's going to be pi, comma 0. And there's our one complete period of sine. So now let's do a little harder one. So this one, notice how we're not in standard form. So quickly, let's just do that. For sine, let's factor out that 2. That's x minus pi over 3. So amplitude we can see is 4. The period is once again pi. And now we have this phase shift. We're going to make that pi over 3 to the right. So let's put a right arrow. The book likes positive and negative, but I like arrows. Let's put an arrow. Perfectly fine. To graph this, we're going to do the exact same thing. Make a T. You're going to go 1, 2, 3, 4. Make the fourth tick mark your period, which is pi. And then same thing, so that's pi over 2, pi over 4. This is 3 pi over 4. And then we're going to mark our amplitudes. That's 4, negative 4. There's our 0. And again, it's sine, so we know it starts at the middle. But I'm going to make it a dotted line. So I'm going to make my sine wave dotted. And it's dotted because this is considered kind of like the parent graph. We haven't shifted it yet. So that's why we want to understand this dotted line is not our final graph. Notice how it's pi over 3 to the right. So this takes a little bit of fraction work, but you have to understand pi over 3, I'll do this in red, is going to be past pi over 4. So think of pi over 3 as like 60 degrees. That's going to be right here. Now, as far as the shift goes, think of this as like a little more than one tick mark. So every single dot, I'll do this in black here. Look at these dots right here. Shift every single one tick mark and a little bit. So this one, we're going to go one tick mark and a little bit. That's right here. This next one tick mark a little bit. That's right here. This next one is going to be down here. And then this last one, this next one is 5 pi over 4. So our last dot is going to be a little past 5 pi over 4. So now let's sketch it in. And right there we can see the shifted wave. Now, of course, we got to label it. So all we got to do is just add pi over 3 to everything. So this first coordinate, I'll do it in red to keep it consistent. That's pi over 3 comma 0. The next one is 7 pi over 12 comma 4. That next one is 5 pi over 6 comma 0. And again, all we're doing is we're adding pi over 3. So that one is just pi over 2 plus pi over 3. The next one, 3 pi over 4, we're going to add pi over 3. So again, I'll write that down here for you. So this point is going to be 13 pi over 12 comma negative 4. And this last one, that's going to be 4 pi over 3 comma 0. And there it is. We shifted the sine curve. Okay, let's go to the next one. Determine amplitude and period. So now we have a cosine wave. So cosine is like the exact same thing. Your amplitude, that's going to be 3 because we want to keep that positive. The period is going to be 4. Now the period, let me kind of go through that just to make sure we're all okay. When you do 2 pi over 2, that's like saying 2 pi times 2 over pi. Pi's cancel, and that's why your period is 4 here. Now for cosine, let's make our t. 1, 2, 3, 4. Fourth tick mark is your period. 4 is convenient because, look at that, 4, 3, 2, 1. That's very nice. That's 0. The amplitude is 3 and negative 3. Okay, now for cosine, hopefully you remember cosine starts at the max or the min. So I'll put a note for you. Cosine starts at max or min. In this case, there's a negative there, so it starts at the min. So put a point at the negative 3, and then just complete your wave. There we go. There's our cosine wave. 1 period. So 0, negative 3. This is 1, 0, 2, 3, 3, 0, 4, negative 3. And actually, while we're at it, this is important, so really make sure you highlight this. Cosine starts at the max or min. Let's add above here, big star. Sine starts at the middle. That'll be extremely important to remember. Hopefully you recall that from your trig class. Okay, so here's the last one. So a little more complex. Let's first put in standard form. Y equals 2 cosine 4 x plus pi over 4 minus 1. So our amplitude, we can see that is 2. Our period is pi over 2. Our phase shift is going to be pi over 4 to the left. And notice I have a negative 1. We're going to call that the midline. So ML negative 1. So I'm going to show you the midline method, and I'm also going to show you a method I call reconstruction. So first, I'll start with the midline. So do your t. Here's the y-axis. But instead of making the middle a solid line, we're going to make it a dotted line. And we're going to put negative 1 right there. And that's going to be your midline. Now use the amplitude, so we're going to go up 2, so that's going to make this 1. Go down 2, that makes that negative 3. Now notice how the x-axis, you still got to draw that in. That's right between negative 1 and 1. That's right here. Now notice how we're using this now to graph, because this will be a lot faster. Everything is in respect to the midline, so we're going to put your 4 tick marks on the midline. 1, 2, 3, 4. The 4th tick mark is going to be pi over 2, which makes the second one pi over 4. This is pi over 8. This is 3 pi over 8. And now we're going to graph it. So ignore the shift for now. Just put down the dots we know. Cosine starts at the max or min. This is positive 2. So put a point at the top, middle, bottom, middle, top. And again, you can make this a dotted line so you can kind of see the graph. So we understand that this is like the skeleton. This is where we're starting. We have to shift this graph, and notice how pi over 4 is the same thing as saying like 2 ticks. So of course we could do what we did in the earlier example. So if you look at this example, we shifted every single point the same amount. You could do the exact same here. These 5 points, shift them 2 tick marks left, and you're done. I'm going to show you a method I like to do. I call this reconstruction. Reconstruction. Not every teacher teaches this. Some of you may like this, some of you won't. It's just a second method. Reconstruction says grab a max or min point. So for this one, I'm going to actually grab this point. I'm going to shift it left 2 ticks. So this whole point, our new point, should be right there. So hopefully we all agree that this point, the new point, is right there, shifted left 2 tick marks. Now the difference is in reconstruction, I'm going to reconstruct the graph around this point. Because in trig, you should have learned that trig graphs are very predictable, which means you know what has to happen next. So if you're at the max here, if I'm moving right, the next point has to be at the middle. And the next point after that has to be at the bottom. And moving backwards, if you're at the max at the middle, going left, the next point should be in the middle, and the next point should be at the bottom. And then you just connect it. And there it is. There's your reconstructed wave. Now, some people think that looks like a negative cosine wave, and that's true. That's because when you shift sine and cosine waves, they often just become like a different equation of a sine or cosine, because they're like the same wave. But ultimately, this is just another method you can use to graph pretty much any sine, cosine, tan, all these graphs in trigonometry. You can do this method called reconstruction. Now, if you didn't want to do that, that's okay. In red, all you would do is just move every single point. So your answer would look something like this in the red. But notice how it lines up perfectly with the blue answer I put. So either method you do, and the red is going to be your traditional. Of course, it'd be labeled and cleaner. I'm just showing a shorthand version. You can do either method, traditional, or you can do reconstruction. I take either in my class. Either is fine. Okay, good job.